Hello programmers, this presentation covers C++, characters and strings. Topics in the discussion include literals, information about characters and character codes, control characters, manipulating characters, C strings versus C++ strings, information about C strings, and information about C++ strings. Let's look at character codes first. Character codes are using a unique binary code for every character. ASCII stands for American Standard Code for Information Interchange, uses 7 bits, and it is based on the old teletype machines. Teletype machines were actually the original input-output devices for most of the computers because it was something that was available. It was heavy and it cost about $1,000 back then, maybe worth $5,000 today, and it could do 10 characters a second. IBM mostly used the EBCDIC code set. It was the extended binary coded decimal interchange code, and it was based on punched cards. The problem with punched cards is, especially when you're encoding things, is that there was big holes in a couple places in the alphabet as far as the codes went, because that's just how it happened to work out with the punched codes. Unicode is a 16-bit code that's kind of extendable. ASCII is great for American characters, but if you look at French, it has that cedilla, that little thing that hangs on the bottom of the C, and then there's the umlauts with, in German, the little 2 dots above a bunch of the letters. Then there's all sorts of accent marks, and then there's also, we have things like Arabic and Thai and Japanese and Chinese and Hebrew and the Cyrillic from Russia, and then there's the Greek. So there's all these other characters that just don't fit in 8-bit. So in order to sell computers all over the world and make them useful for everybody, we extended the ASCII character set to Unicode. So the first 128 characters in Unicode are ASCII. We don't see it anymore, but there's the Baudot code, which is the original teletype code. It only had like 5 bits. And you had to do a shift in order to get the numbers, and then you do another shift and you get letters again. Baudot became somewhat popular, and it's still being used by the teletype for the deaf, because after the 8-bit or the 7-bit teletypes came out, then all these old 5-bit teletypes became obsolete, and the deaf population started using them. Here are some examples of codes. The capital A happens to be a 01000001. Now that's 8 bits, but the top bit in ASCII just isn't really used, but we still have to put it there because the computers typically store characters in 8 bits. Here's the letter S, 01010011. If you look at EBCDIC, they're just like totally different, and I've only used EBCDIC on a couple machines, and that's on the IBM big mainframes. Otherwise, even the IBM PC decided to go and use ASCII. Here is the ASCII character set. If you look at it, the first 32 characters are control characters, and then we have the letters in the alphabet. Whoops, not yet. Then we have a bunch of characters, and then the characters 0 through character 9 and some other stuff. Finally, we get to the letters in the alphabet and a few more things, and then the lowercase letters. What's interesting here is to look at is that all of the capital letters occur before the lowercase letters. The original teletypes didn't even have the ability to do lowercase letters. When I used to get my paycheck from school, everything was capitalized, even though it was on an IBM mainframe, because they didn't buy a printer that even had lowercase letters. It is most common when you're a programmer to express things in hexadecimal. So if I look at the hex code for the letter A, it says 41. So that's I can go over to this other chart over here, hex to binary. A 4 is a 0100 and a 1 is a 0001. If I look at the letter S going down, it says 53. So that's a 0101 0011. As a programmer, I would highly recommend learning that hex to binary conversion chart. You really need to memorize that thing. As far as memorizing the character codes for ASCII, well, I think it'd be good just to memorize a few of them, like the letter A and maybe the letter L. Then you can go up and down and figure out the differences. Going on the hex, look at the letter A. So that's a 0100 0001. But in the lowercase a, it's a 61, which is a 0110 0001. So then there's only 1 bit difference between the capital letters and the small letters. Here are the control characters. Most of them, as a programmer, you probably will never use. These guys originally were used especially in transmitting data back and forth between different computers. So we have things like null, you should know that one, that's all zeros. And then start a header, start a text, end a text, we don't really care about those. End of transmission, I'll cover that one a little bit. Inquiry, ACK, that's a positive acknowledge. Look over on the other side, we have a NAC, which is a negative acknowledge. And then there's the bell, ding, BS, backspace, tab, line feed, going down, carriage return, and escape. So the ones that are in bold are ones that you probably should memorize, like backspace, tab, new line, carriage return, and escape. Literals. In computer science, a literal is a notation for representing a fixed value in source code. For example, I'm going to define a character. I'm going to call it CH, and I'll say equal, single quote, capital X, single quote. When we define a single character, it is done with single quotes. If I want to define a character string, then I use double quotes. So character, str, open, close, square bracket, equals, double quote, X, double quote. Now this is a string instead of a single character. Here's some backslash escape sequences. Backslash A, short for announce, it'll ring the bell, ding! Backslash D, into file for Windows, and going down I see a backslash Z, into file for Unix. So if you're like typing a file from the keyboard into a text file, if you're on Windows, then you can use the Control D to do end of file, or Control Z to get the end file in Unix. If you're on the keyboard, you can use the control and then the letter in order to get these special codes. But if I am inside of a quoted string, either a single quote or double quote, I need to use the backslash character in order to get the control characters. So you may already be familiar with the backslash N for a new line. Well, you can also do a backslash R for carriage return. Depending on what device you're working with, that will bring the cursor back to the beginning of the line, and then you can overwrite whatever you had before. Backslash T is a tab. Backslash open square bracket is escape. We need, since the backslash is being used as an escape character, I need to use a double backslash in order to actually get a single backslash when I am inside of a quoted string. Backslash single quote is a single quote. If you're in a quoted string, you say quote, hello, end quote. Well, what happens if you want a quote on the inside of a quoted string? Then you have to use a backslash quote on the inside. So that will actually give you the double quote on the inside of a quoted string. Backslash 0 is a null byte, and we'll see that used a little bit. Here is a couple differences. Character CH equals single quote X single quote. So that is going to put an X in a single memory location, or depending on whether it's Unicode, if it's just straight character. It might be single byte or Unicode, double byte, 2 bytes. But it is a single character. In C and C++, we're using C strings. So that is actually going to use an array. So I have to use an array, and I can say character str, you can call it anything you want, but opens, close, square bracket equals double quote x double quote. Strings end with a null byte, and that's how in C we can tell we have the end of string. Some languages, I remember back in the old days of Pascal, they use the length of string as the first byte, and then the rest of the characters in the string were characters. But in C and C++, the terminator is the null byte. Now I have a couple ways here. I can say character str has defined a string, a double quote, x double quote, so it has the letter x and then the null byte. If I say hello, I have the codes for HELLO and then a null byte. Or if I just say character string equals double quote, that's a null string. So it is still using a single byte, but it has the null byte as the first indicator in the string. Here's some different ways to define a string. Character star str. Well, that one's good too, and that does pretty much the same thing as character str open close square bracket. But now it's the pointer notation instead of array notation. It doesn't matter how you define it. You can use character notation or array notation in C and C++ when you start accessing the characters. I can also define a string using a collection of individual characters. So I could say character string opens close square bracket equals open curly brace single quote H single quote comma, and then the rest of the letters, and whoops, I'm missing a comma, right? No, it's there, sorry, I thought I was missing something. But I'm going to have to define the end of null myself. If you use a quoted string with the double quotes, you get the null byte. But if you're doing it yourself, you have to make sure you put the null byte in. And you can either use the single quote backslash 0 single quote, or you could even just use a 0. I could also define it with the hex codes for each letter. So the hex code for the letter H, if you go back and look at the ASCII chart, is a 48. In order to get a hexadecimal literal in C or C++, I have to start with 0x. You really have to be careful, because if you ever start anything with a 0 while you're coding in C or C++, or even inputting things from the console, 048 would be an octal 48. It's not too popular anymore, but it was when C was first created. So watch out for starting things with a 0. I could also define it using the decimal equivalent. So the decimal equivalent of a capital H is 72. So 72 is also the same thing as hexadecimal 48. It's also the same thing as a capital H. So in any case, you still end up defining HELLO and a null byte. You need some header files. If you're writing a C program, I'm going to use ctype.h, and that's for character typing. Also includes string.h. C has a whole collection of string routines. Now watch out, because if I move over to C++, the equivalent of ctype.h is cctype without the .h. The equivalent of the cstring.h is cstring without the .h. And C++ has its own string routines, and that's just with pound include, open angle bracket, string, close angle bracket. Here are some functions to manipulate characters. These are probably the most popular ones. Is alpha, is digit, is alnum, is space, is lower, is upper, is x digit, is control, is print, is punct, is for punctuation, that's for like period, comma, etc. Is graph, well, that's the extended ASCII. If the top bit is turned on, then we get some weird graphical characters. To lower and to upper, those are actually converting characters, so they will output, change the letter to lowercase or change it to uppercase. The other ones that start with is, they return a true or false. C strings versus C++. So a C string is an array of characters that are terminated by a null byte. In C++, we have a string. It's almost like a string data type. It's really an object-oriented thing, but we pretty much can treat it like a data type. So if I said string str in C++ equals hello, what's happening here is we're taking a C string and converting it into a C++ string and storing it in an object. So these objects have the length and all the characters, and they have all of the operators that are available. So it's usually pretty much, it's a lot safer to use C strings because they take care of a lot of the memory management that you would have to do yourself if you're doing C++, if you're doing C programming. Into the C string library. I'm going to cover the original C string library, deprecated C string functions, printf, string token, and string token underscore s. I won't cover those, the printf or the string token, in this exercise because each of those really should have an entire presentation on their own. They're so complicated and so powerful. Here are some of the more popular C string library functions. strlen returns the length of the string. strcat, that's a concatenation that adds one string onto the end of another string. strn, that's the end there has an extra parameter in the call so that you can limit the number of characters that you're adding on. strchr, that does a search. That's going to look inside of a string to find the location of the next string. Find the location of a character in a string, and if it doesn't find it, it will return a null. So strrchr, that's start looking from the end of the string instead of the front. strstr, that's looking for a substring within a string. Now I'm looking at some of these things where it says returns int, returns character star. So if it returns character star, that's returning a pointer to wherever either the for string cat, it's returning a pointer to the original string, and strchr returns a pointer to where it found something. So we have string copy, string end copy, that limits the number of characters that are being copied. There's string compare, I'll cover those more. And then there's str case compare. Well, it seems like everybody else in the world uses strcmp or stricmp, for the I stands for ignore case. But Microsoft decided they wanted their own version, so they have strcasecmp, where everybody else uses stricmp. Well, they can do that because they're Microsoft. Here are some examples. String length. Now, string length is really, what that does is start at the beginning of the string and then starts counting until it finds the null byte. So if you have a big long string, that'll use up a few memory cycles. Here's an example, defining a string, quote, dan, quote, and the length of the string. So if I int length equal strlen name, that returns a 3, not counting the null byte. Remember, the size of the array there is going to be 4 because it has DAN null byte. The array size is 4, but the length of the string is only 3. String compare. I want you to look at how this thing is written, because when you start using some of these functions, you're going to be seeing things like this. Int strcmp const character star s1 comma const character star s2. So that right there is the function prototype, and I can tell it's a function prototype because it's ending with a semicolon and it does not have a block of code there. What happens here is we're going to compare character by character, and as long as they're equal, they're exactly the same, then we'll go to the next character and compare them in the two strings. And then we'll keep going until we hit the null byte in both strings. If that's the case, then both strings are exactly the same. If we find characters in the same position for the two strings that are different, what happens is it takes one and subtracts the other, and you can end up with a result. So therefore, if I compare Dan with Don, it's going to return a value less than 0, because if I take the code for the letter O and subtract the code for the letter A, if I take the letter A and subtract an O, I end up with a negative value, because the letter A, the code for letter A, lowercase a in hexadecimal, would be 61. And the code for the letter O would be a 6F. So if I take one value and subtract a bigger number, then I end up with something that's less than 0. This is good if you're trying to sort things, because you can go through and sort them. Now watch out, because if you have something like alpha 2 and you compare it to alpha 12, well, alpha 2 is greater than alpha 12 because it says A's are the same, L, P, H, A, and then it sees a 2 and compares that to a 1. Uh-oh, that comes out bigger. So I think some people have written things to actually see if I have numbers and convert it into an integer, but string compare just looks at the characters one at a time. Okay, now comparing Dan with Don. So if you go back and look at the ASCII character set, all of the capital letters occur before the lowercase letters. So now, if I look at it, Don has a lower value than Dan because I'm comparing the letter A with a capital O. We can solve that with strcmp, or if you're Microsoft person, then strcasecmp. Now we're going to ignore case. So now the lowercase a is still less than the letter O, even if it's uppercase. String copy. Character star strcpy. That means that right there, character star, that means I am returning a pointer. So this is like a position. I'm actually getting the address of the position in the array. So string copy copies the string, the second one. So if you think about it as like an equal sign or an assignment, string 2 is going into string 1. You have to watch out though, because these are not very safe, because what happens if the array defined for set aside for string 1 is smaller than string 2? Well, we're going to start copying stuff, and then we're going to run off the end of the array that we had defined for string 1, and we're going to start destroying other parts of memory. And people have come up with things and like try to figure out how they can crash a system doing like that. So they're recommending that you use strncpy. That way the n provides an extra argument in the call, so that you can define how many characters you want to copy before you stop. Here's strcat. That's going to copy string 2 onto the end of string 1. So you got to make sure that there's enough room for string 1 in order to hold the extra data that's being added onto string 2. So this guy here is not any good because first name is Dan and last name is McElroy. So I'm going to copy McElroy onto the end of Dan. But look, the array size for first name is only 4 characters long, including the null byte. Now I'm going to try to add on a whole bunch more, and there isn't room. So I'm going to overrun the buffer, and no telling exactly what happens. Here's a little better version. I'm defining a third array, and I'm hoping it's big enough. So I'll say full name is 100. So first thing I do is string copy. I copy Dan into full name. So now full name has DAN and a null byte. And then I'm going to copy a space. So now it's going to have DAN space and a null byte. And then finally I'm going to, concatenate. I'm going to concatenate the space on. And then I'm going to concatenate, append, last name onto the end of full name. So now it's going to have Dan, space, McElroy, and then the null byte. There are a bunch more string library functions, and some of these might be defined in stdlib for standard library instead of a string. So there's ATOF, that's ASCII to float, so that will take characters that are typed in. Like if you have a 15.6, if you read it from the keyboard, you have character 1, character 5, character period, character 6, and a null byte. As far as humans are concerned, that looks like 15.6. But as far as programming is concerned, that is an array of characters, not a floating point number or a double. So if you have ATOF, now you can input a collection of characters and convert it into a floating point or a double. ATOI convert ASCII into integer. Memset, memcopy, those guys you can set a whole block of, you can set like an array to all zeros if you want. Memcopy, that's pretty much similar to string copy. I won't cover string token here. If I look over on the right side, I have things that especially Microsoft has tried to solve some of these problems. Strcat, string copy, and string token underscore S on each one. The underscore S means secure. So strcat and string copy, they have extra arguments in the call to make sure that you put in the size of the array that you're putting stuff into to make sure that you don't run off the end. And string token underscore S, that's to make it, if you have multiple programs that are all using the exact same routine, they're making it safe if you're on a multi-programming environment that are sharing library functions. C-string library. We're using class definitions for the string library, and we're building objects for object-oriented programming. So the C++ string library is using objects instead of arrays. Here are some of the more popular string library functions. They have the equal, plus equal. Append does the same thing as the plus equal. Size or length, that returns the length of a string. Resize, clear empty, a whole bunch of these other things. So just look them over so that you have an idea of what is available to you. Back gets the last character, front gets the first character. C underscore str is another function that's available so that we can convert things into a C string. Here's find, those are cool. Kind of like str, chr, and str. So we have a lot of the things that are available in the C library now available in the C++ library as function calls. Here is an example. At the top, I need to include string. So string first name equals Dan. So what that's going to do is that's going to take a C string and convert it into a C++ string and store it in first name. So first name is the name of our object. String is really the class name, but first name is the object that I am creating here in my program. So last name equals McElroy string full name. So I can say full name equals first name plus double quote space double quote plus last name. So that makes it a lot nicer than trying to use all those string copies and string cats. Say length equals full name dot length open close parentheses. So full name is the name of my object, then dot, that means I'm going to access one of the member functions. So length is a member function that does not have any parameters. I have to use the open close parentheses there because it is a function call. So console out, full name, less than, quote, comma, space, length equals space, and then less than, length, and ENDL. So it's going to say Dan McElroy, comma, space, length equals space 11. So that's my first name, a space, and the last name is 11 characters. Here is another example. Do the same thing with string first name, string last name, string full name. Now I'm going to use, instead of using the plus, I'm going to start off, I can say full name equals first name, so I'm going to copy, starting off, I'm going to copy Dan directly into full name, and then full name dot append. So I'm using the append function that is part of the class definition. So full name dot append, then open parentheses, quote, space, quote, close parentheses, semicolon, that says I'm going to append a space onto the end of full name. And then I'm going to append last name onto the end of full name. So it says console out, full name, less than, quote, comma, length, space, equals space, and then full name dot length. So I get the exact same result. Dan McElroy, comma, length equals 11. Well, I hope you enjoyed this presentation, and here it is for today.